So after having understood the interpretation of the divergence and the curl, I would like now to reinforce the actual calculation of divergence and curl. So let's do a problem in which I give you 3 vector fields and I ask you to calculate the divergence and the curl. So just as a refresher, I'm going to copy here how to calculate divergence of f is the dot product between the nabla operator vector and the vector field f, which is given by the partial of the x component of f with respect to x, plus the partial of the y component of f with respect to y, plus the partial of the z component of f with respect to z. On the other hand, the curl of f is given by the cross product between the nabla operator and f, which is given by this determinant. Which I will copy it here because we will be using it. This is x hat times plus y hat times plus z hat times Okay, so that's the recipe for calculating the divergence and the curl. So now let's calculate the divergence and the curl for these different vector fields. So f equals this vector field here. So here I'm giving the vector field in the format of a vector like this. So of course you know that this is fx, this is fy, and this is fz. So the divergence of f, I just need to substitute this, evaluating the different partial derivatives. So the divergence of f is equal to partial of f of x with respect to x, that will be 0, plus partial of f of y with respect to y, that will be x, plus partial of f of z with respect to z, that will be 1. So it will be x plus 1. The curl of f will be equal to, so now I'm looking here at the top right. So partial of fz with respect to y, well, x hat times partial of fz with respect to y, 0, minus partial of fy with respect to z, 0, plus y hat times partial of f of x with respect to z, 0, minus partial of fz with respect to x, 0, plus z hat times, and let's show that, partial of f of y with respect to x, so that will be y, minus partial of f of x with respect to y, so that will be minus 1. So the result is y plus 1 in the z direction. And the result is a vector. Okay? Now let's do b. So b is this vector field here, y, e to the xy, and 1. And you know that this is fx, this is fy, and this is fz. So the divergence of f, we need to do this. So partial of f of x with respect to x, 0, plus partial of fy with respect to y, that will be x times e to the xy, plus the partial of f of z with respect to z, which is 0. So the answer is x times the exponential of x times y. That's the divergence. Now the curl. So to calculate the curl, we can apply our equation, which we have here, and we have to apply it to these functions here. So let's do it. Partial of f of z with respect to y, 0, minus partial of f of y with respect to z, 0, times x hat. Now plus y hat times partial of f of x with respect to z, 0, minus partial of f of z with respect to x, 0. And now plus z hat times, I know you cannot see it, I'm sorry about that, but okay, partial of f of y with respect to x, so that will be y times e to the xy minus partial of f of x with respect to y, that will be 1. Okay, so the result will be y e to the xy minus 1 times z hat. Okay, so that's the curl of this vector field f. And finally, the last vector field. So now I'm giving it, instead of giving it as a vector between brackets, I'm now giving you the 3 components separately. Okay, but it's basically the same thing. So if I copy it using the vector notation, fx is 2x ex times y. Then fy is xy squared cosine z. And then fz is minus y plus z, which we could write as minus y minus z. Okay, so these are the 3 components, fx, fy, fz. So now let's calculate the divergence of f, which is partial of f of x with respect to x. So we need to do the partial of this with respect to x. Now this is going to get messy, right? Because we have to apply the so we could keep 2y as a constant in front, and then we do the partial of x times the exponential of x, where we will have to apply the product rule. So it's the derivative of x, which is 1, times e to the x without derivative, plus x without derivative times the derivative of e to the x, which is e to the x. So that will be the first term, partial of f of x with respect to x. Let me copy the calculation of divergence and curl on the bottom so that we can see it at the same time as I answer. Okay. So the next term will be, we already calculated this term, we need this term, partial of f of y with respect to y. So let's keep, okay, it's x cosine z times 2y. Okay, and then plus the partial of f of z with respect to z, that's simply minus 1. Okay, and that's the result for the divergence of f. And now finally, the curl of f. And we have here the recipe. So it's x hat times partial of fz with respect to y, that's minus 1, minus partial of fy with respect to z, that will be minus xy squared sine z. Yes. Then plus y hat times partial of f of x with respect to z, that's going to be 0, minus partial of f of z with respect to x, that's going to be 0. So that's 0. And now plus z hat times partial of f of y with respect to x, so that will just be y squared cosine z, minus partial of f of x with respect to y, that will just be 2x e to the x. And that's it. That is the answer for the curl of f, which is a vector field. Okay? So now you know how to calculate the divergence and the curl in many different examples. Thank you for watching and see you in the next video.